All right, so we're determining the type of growth that is shown by the pattern here. We also need to write the expression that represents the type of growth, and we're going to find the total number of squares in the fifth figure in this pattern. So as usual, let's start with just, for me, I like looking at the total number in the figure. So figure 1 has 4 squares in total. Figure 2 has 7 squares in total, so 5 on the bottom and 2 on top. And figure 3 has 10 squares in total, 7 on the bottom and 3 on top. So how is are these changing? That's a plus 3. That's a plus 3 as well. So if I were to go ahead and draw figure 4, what I'm noticing for each figure is how is it changing? What's staying the same and what's changing? Well, there is a middle square that's in each, and I have n, n, and n. This is n right here, n right here, n right here, n, n. Okay, so for me to draw figure 4, it would mean that I would add 3 extra squares each time, because that's what I'm noticing. So figure 4 would have 9 on the bottom, so 1 in the middle and 4 on either sides. All right. Four on either sides, and I'll do 4 on top. So this would have 13 squares, and if we're looking at the pattern from 10 to 13, that's also a plus 3. So if we should construct a table to show us our table of values where x represents the figure number and y represents the total number in the figure, I always like to think about, well, what was the step 0? Because that's going to be important. We don't know what that is right now, but we're going to assume. Step 1 had 4 squares. Figure 2 had 7 squares. Figure 3 had 10 squares, and 4 had 13 squares. So based on what we're seeing, you notice we're adding a plus 3 each time, a plus 3 each time, which we can reverse that action. So if we're adding 3 each time, how can we find out what figure 0 would be? Instead of adding 3, we can subtract 3. So if we take 3 from 4, what that does is we notice it leaves us with 1. So we are subtracting 3, which means we're going to have 1 here. So what are some of the things we know so far? This shows constant rate, which means it's going to be a linear growth. For linear growth, we use y is equal to mx plus b. We know our m is our rate, so the constant rate, m in this case is going to be plus 3, and b we just found out is a positive 1, because that's what we're getting in step 0, because b is our y-intercept, and that occurs at step 0. So the expression that gives us this pattern is going to be equal to y is equal to 3 times n plus 1, and we're seeing 3n each time. In our diagram, we have n on this side, n on this side, n on this side. So it's going to be 3n plus 1. So if we want to find when n is 5, then we can use this. It's 3 times 5, that's 15. 15 plus 1, that's going to be equal to 16. There you go.